Good, I see 4000 upload speed, and we can start. So the purpose of this lesson was to extend the previous lesson and to add more examples and continue on previous points of how to write a code which is easy to understand for humans, which is easy to navigate and maintain. So the most basic of rules will be introduced today. So first, what is clean code? It's code, like I said, which is easy to read, understand, and maintain. And I think we've all been here in a situation where you see someone asking you to help them with their code, and it's actually trivial code. It doesn't do anything complicated, but the way it's written is so difficult to understand, and if you just do whatever and don't care about naming standards, about writing it as clear as possible, and about caring about someone else who will have to read your code, even about yourself after the future you in like a month or two, then it will be a big problem. So in this example, you see what happens when everything is in a single file, when there is a problem, but everything is in a single file and everything is named as ambiguously as possible. It's a big problem. Though this situation is unfortunately quite common in beginner developers code. So why do we need clean code? Most of the time we don't write code. Most of the time we read code. 1 to 9 is the ratio we spend writing code to reading it. So the dirtier the code is, the more time it takes us to remember what we wrote, find what we were doing and what went wrong, and then it makes someone else getting into a project really complex, as you will have to explicitly explain what you did, and in worst case scenarios you would have to keep on explaining yourself what you did because it's inconsistently unclear what you did.
And are you actually streaming something?
Yes.
Because there's just blackness on your screen.
Really?
No, it's okay.
It's okay for us.
Okay.
That's it?
Oh, test, getting some echo when you speak, test, okay. Is this not chapter 1 in every programming book ever? No, it's not chapter 1 in every programming book ever, because this is actually very, very missed in most programming books. Unless you explicitly look for that, for learning how to write clean code. People don't cover, well, maybe the thing is that in universities people are being taught to comment everything, literally. But the purpose of this is to explain themselves, to double check if the student understands what he wrote, what he or she wrote. But that's where misconception comes, that everything should be commented. No, everything should not be commented, because that's for learning process. Total commenting is for learning process and not for actually the comment to code ratio should be no more than 1%, I think. If you're not learning, it shouldn't be more than 1%. So I'll try to explain why, and among other rules and things. And the clean code series is not something that I'll explain in a single lesson. It's going to be 5 or 6 lessons. And it will also involve writing tests. Yes, 1%. Because comments, well, I'll explain. So, we'll see. So in the end, clean code is needed because it improves our productivity immensely. So, you know, people, like 3 years ago, I would ask myself, how can I define quality of my code? And then I would think about lines of code, about tests, about amount of files, classes, and then nothing really comes to help as much as this measurement, which is WTFs per minute. So when you come to a code review, or when you show your code to someone else, the less explanation you explicitly need to do, and the less what the fucks the other person says about your code, the better it is. And code will always have those WTF moments, but it shouldn't be all the time. It should happen rarely and not often. So this is how code review looks like when it's bad on the right and when it's good on the left. On the left a few WTFs, and on the right it just keeps on going. So the first part about clean code is naming, and naming things is the hardest things, one of the hardest things that programmers have to do. So the problem is that with naming we have rarely any restrictions, and some languages completely do no restrictions at all. On the right, I'm not sure what language this is, but basically you can make up your arbitrary aliases for types and values, and if you do this, your code could look like what you see on the right. And may God help someone who would have to maintain this code. I know that this is like super exaggerated example of what a dirty code looks like, but sometimes when you work alone, you might get those bad habits of naming poorly, or naming in not the best conventional way possible. So don't name anything with names that only you can understand, and try to be as expressive as possible with your naming. And let's see examples of good naming. So names should be unambiguous, like names for a single character, or something like index when there is a lesson entity, and let's say a lesson index, and you name one index and the other one lesson int or lesson object. Well, it's ambiguous, and it could be better named. So on the left you see good examples, and on the right you see bad examples. Lesson says what it is, or what it is used for. So for an index, lesson means it's index of a lesson. It becomes a bad example if I have a lesson object and a lesson index. So under, prefer not to use types at the end. Lesson int just says that it's an integer for a lesson, but it doesn't show purpose. Lesson index means that we will use to iterate through the lesson. We say which index value of our lesson it is. So we will iterate through lesson. It shows our intention immediately. Int doesn't. Lesson should be by default an entity. That's why we don't need any prefix, and that's why it's clear what it is. Also, this example, lesson itself should not have a type as the type is obvious and it can be guessed by a compiler based on the type we use for the new keyword initialization. So var is enough in this case. And that's for that reason we also don't need lesson object, because it's just noise and doesn't give any information. So our variable names should be as small as possible, as long as they contain the needed information. Minimal enough information. So shop is a good enough name. As in constructor, let's say we say whose shop it is or what type of shop it is. So name on the right is just noise, as it doesn't really tell any new information about it, unless we will explicitly be dealing with it. But we don't. If this is the context we have, then we should choose the shorter name. Is this for the fourth rule for naming, that we should name our methods and variables in English? This is very, well, not common, but happens more than it should when people go to school or university without having programmed at all before, since they require to explicitly comment everything, and those comments sometimes are in their own native language. They also do the same in the code to use native names, and that's a horrible thing, because by writing in native language you make that language, the programming language, inconsistent with language keywords, which are mostly in English, which are always in English actually. Well, doesn't have to be, but mostly are. So as opposed to your native language, which is in your mother tongue. So don't write in native language, as it makes language inconsistent. So names should be easy to pronounce. For example, if there is a long word, just to read it for yourself will take half a second to a second, as opposed to, let's say, an alternative shorter name, which would take like 0.3 second. Or sometimes you would read a more difficult word several times until you can pronounce it or understand what it means. So names should be as trivial as possible, as simple and as short as possible. Easy to read, easy to understand, easy to pronounce. One thing that programmers don't sometimes understand is that if there are conventions in general, they should be followed. But if the team you're at have their own conventions, you should follow those instead of general conventions. Because what matters the most is teamwork, is consistency inside the team. And even if those conventions are against the general language conventions, you should follow your team conventions. So if, let's say, your team says that all entities will have entity suffix in the end, then you should have that, though language convention doesn't say it. Worst thing would be that in some places you do add entity suffix and in other places you don't. By being inconsistent is the worst thing you can do. And the smaller the scope of inconsistency, the worse it is. Like, being inconsistent, like, inside the same method is horrible. Being inconsistent inside class methods is really bad. Being inconsistent between classes, class names, is quite bad. Then being inconsistent between namespaces, naming your namespaces, is also bad, but the less the scope is, the worse it gets, because you won't know what to expect. And since you deal with it more and more, the less the scope is, it will be simply harder to work. So prefer convention by default, unless there are rules that you and your team made arbitrary and agreed upon. And finally, don't use keywords for names. Never, ever, ever. For example, if I make a console application, and if my namespace is called console, you'll have a lot of problems by calling the console class and using the console namespace, because your namespace has the name too. So don't use keywords in namespaces, because don't use keywords in naming in general, because it is problematic. You want to reserve them for what the language offers. And of course, let's say you work with NVC, you have model, view, controller. Have those suffixes in them, unless again your team says otherwise. So those are the basic naming rules. Now about the type. C# is one of the languages which lets you explicitly specify the type, or let the compiler decide what it is through the var keyword. And in most cases you should prefer var over explicit type, but there are cases when you would like type to be specified explicitly. So if it's hard to tell what type it is, for example, get amount. Amount can be a float, amount can be an int, and I will have to explore the method in order to know what type it is. In this case, use an int, or rename variable better, name better. But it's quite hard, and in this case it makes sense to explicitly say that amount is an integer. Now, if something is really important, like if you want to put emphasis on the type, just let's say you read something and you want the reader to read the type to emphasize the importance of it, then you should also add explicit type to that as well. That is another important thing, as opposed to hiding it when you want to say how important the type is. And lastly, if your team says that explicitly specify and define types, do it. Don't argue with the team. That's the most important thing. And using var in all of the cases is good because it provides no extra info, so you're just saving some time by reducing the time to write the type. Sometimes type is obvious, so you don't get any extra info from var. Sometimes you don't care about the type, so writing it, figuring out what it is, would be useless. And when you write 3 letters as opposed to main controller, for example, you save a lot of time, so it's much faster. That's why var is preferable in C#. So think about your naming well, but don't spend too much time. And this is a funny example about overdoing it a bit. And you should probably stop because you should probably stop at the first level. Just take enough time, but not too much time, figuring out the name, and don't spend forever for a single variable, because, well, there are other priorities. Sometimes it's good enough, And it's a skill that you have to build upon, and it doesn't come immediately. So with practice, you will name things better as you will understand what you yourself found difficult to understand in other people's code or your own code after reading it after some time. So looking back in retrospective at yourself and your team and others in general, you will get better at naming. So spend some time, but don't overdo it. And if you're curious about full C# coding standards, there are two sources, and both are quite good. First one is the community source. It's a GitHub page, GitHub wiki, which contains a bunch of rules with examples in an easy to understand way. And a more official source, of course, is MSDN, the official Microsoft Docs. So I highly recommend checking both out. And this chart summarizes the basic conventions, which is, I would like to emphasize, Pascal case, classes and properties, camel case, method arguments, Pascal case methods too. Basically, any name for any code structure should be, for any type structure should be Pascal cased. Names for methods should be Pascal cased. Camel cased should be arguments and local variables. Also, Pascal case should be constants. Fields, I see camel cased, but there is an underscore to them. So the only thing we use underscore to in C# as convention is in field names. We don't ever use snake case, which is separating words with underscore. We don't use that. In some languages, it's preferable to write constants that way, where you write constant in all capitals and separate different words with underscore. But we don't do that in C#. That's Hungarian notation. We use Pascal case for writing constants.
I have a question.
Yeah, go on.
Okay, I see that we can use numbers on naming.
We can use numbers.
Okay, numbers on naming is not a bad practice.
It's not, as long as it's logical. For example, you have address 1, address 2. That's an alright variable property or field name because it says the first line, second line. It's obvious what it's for. It's sometimes useful.
Okay.
But
I mean,
mhm.
Okay.
Do you have an example? Some to illustrate the question better?
Oh, I suppose if we take data from a table which has numbers in their columns.
Mm-hmm.
I understand that. I can understand that, but I can't see another example.
Mm-hmm.
I mean, having a name for a property which is 100 characters and has numbers in it, I think
No,
that.
no. It's bad. It's already bad.
Okay, yeah.
Too long name. So don't go more than, I would say, 30 symbols. If you go over 30 symbols, I will not read it anymore. I'll just read a few words and I'll say, okay, I forgot what I read already. So don't go into such extremes as naming with so long names. Alright. Any more questions?
No.
Okay. So this is a really good quote, and I recommend saying this to everyone you work with. So always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. Understand that someone will most likely take over your code, especially when you work in a team. If you work at work, that will happen too. You will eventually move on to the next project, and someone will have to maintain the code. And actually, there are so many cases where a programmer is reading his or her code and then starts ranting, "Whoa, what the fuck? Who wrote this shit?" And then checks the comment history and the name is of that same person. And this is such a common thing. Programmers improve and they improve quite fast, but sometimes time is a constraint to which we have to give in, and sometimes we just forget trying to be more clean and more clear with how we write our code. But just spending a little bit more time daily for making it more understandable will give us great long-term results. Short-term, yes, it's a bit inefficient, but long-term, hands down, it's worth it. So the first thing is about boundary conditions. Those are the conditions also called edge cases, and they're very important. They're very important because, first of all, we need to test them, but that will be in the second slide. In either case, we need to encapsulate the boundary condition. Boundary condition needs encapsulation because we name the boundary condition. So let's analyze the examples. In the first example, we see that level index +1. I don't know what +1 means. As a programmer, I understand that it says the next element, but it would be more clear if I name it as such, because I need to process the plus operation and put that in a context. If I put a name instead, I don't need to know, I no longer need to know what is it used for. It's obvious already. So the second to the right example is much better because next level, it already shows intention, what +1 does, and since we use it twice in the if and in the method, we already avoid a little bit of repetition and we make our code a bit more readable. And we handle our boundary condition because it's that important. You don't want to handle it externally outside of your class. You want to hide the details, how you handle it. So if there are no more levels, I'll throw an exception saying that there are no more levels. And the best is to encapsulate both moving to the next level and going to any level. So it becomes quite simple. This depends, but I think I would agree to you that go to level should be public. Because if you don't want this to be exposed as a detail to navigate levels freely, this should be encapsulated and made private. It's an unnecessary detail. So you have those boundary conditions which you explicitly handled, and you should test it. So when you write tests, you test your function. And your function has, if it has boundary conditions, you should include those as separate tests. And this especially applies to third-party libraries when you write integration tests for it. Or if you're exploring it, you, let's say, don't know what it does, how it works, so you can write tests to better understand. If it, especially if itself does not already provide tests. If it does, well, you can just reuse those. So those tests will be a self-documenting code, and it will help you better understand to which parts of the function, to what cases you should pay more attention when dealing with a class. So in our case, our edge case is, our boundary condition is the last level. So if it's the last level, it should throw no more levels exception. So that's what our test checks. And this, by the way, is XUnit, because we have concept of facts and theories. All right. So just like Dance With Me 123 said, we should hide details that we do not need. We should encapsulate them nicely. I'll go one slide before. What does the fact do? I've seen something similar with Entity Framework, but not sure if it has the same result finality. It is used purely with XUnit, and you have facts and theories in XUnit. Fact is a test which requires no input. So it's hard-coded test, and just like a fact, it means that something that the test tests will always happen, no matter the input. So you only have to pass some single hard-coded value to it, and it will not change the outcome of test. So you call it a fact. It will always give the same outcome. The assert will not change based on the input. So other concept would be theory, and theories enable you to pass inline data. So you can pass, let's say, 1 as inline data, and it will say that it's the first element, the index number, for example, as a parameter to that test. So facts and theories. Facts, hard-coded tests; theories, parameterized tests. So it's just for testing, so I'm pretty sure it's a different concept compared to Entity Framework. So encapsulation and boundary conditions and boundaries, interfaces or entities through which we communicate or through which we access something that we need. So this is an example taken from Java. Java has a map class, and the map class has a bunch of methods. And let's say our case is that we only want to get a sensor by ID. That's all we want, nothing else. And in the end, we will still need hash map, because that suits our needs the best. But at the same time, it has so much more than we want. We don't want to re-implement hash map. It's too inefficient. But what we can do is to wrap hash map into our own class and expose only what we want, only the minimum that we need. And in this case, we have a sensors class, and the sensors class acts like a repository which holds our sensors in a private sensors map, hash map. And then we can simply call getID, and that's it. We get sensors by ID. We implement that method, which wraps the hash map. So like this, we eliminate the details we don't need and have only the small bits and pieces that we need. So that would be the clean the clean implementation of getting sensor by ID, if that's all we need. So very often we work with primitive types, and we tend to pass a lot of them very often. But sometimes those primitive types, values of them, violate business rules. For example, if we have a phone number, and a phone number has a set amount of digits based on a country, it has a country code, but in the end we would pass a string to it, or an integer. If we pass a string or an integer, it can be a 0, it can be null, it can be an empty string, it can be a string with a dot, and so on and so forth. And we don't want that. We want to validate those rules. And the best way to validate those rules is to handle them in our own custom class. So we should make our own class which works through the filter of our business rules. So I'll quickly go to Visual Studio to show example. This part for Lithuanian phone number might not be the best, but let's cover the phone number part. So we have a phone number class, and when we pass a string, which should represent a phone number, we check if there are any symbols if there are any invalid symbols, we will throw invalid phone exception. So our phone number is no longer a string, it's an actual phone number. So we can get the digits or get phone with the country code, like here. And this class is just using open-close principle. Let's say we have our phone and it's done. We don't create phone. We don't create phone number directly, but when we create, let's say, Lithuanian phone number, we'll already have this added. You could pass as an alternative the country code to constructor, but that causes a potential problem with failing it. So it again depends how you work with it, what you need. If you work with national numbers, probably this case would be cleaner, because if you work explicitly with Lithuanian phone numbers, because you don't need to care about passing the code every time you create a phone number. So you should always measure the pros and cons and use whatever is suiting. But my point is that here, and even now, it's not fully handled, because I should probably first check if string is not null or empty, or white space, because phone cannot be empty or white space. So then I would throw invalid phone exception. Invalid phone exception. And I'll call it not enough info for phone. Something like that. So with custom exceptions and custom class handling business rules for a phone, you have no longer a primitive but a dedicated type for handling those rules. So let's continue. Okay, I'll skip this slide. My point was that I wanted to say about negative conditionals is that let's write a test somewhere, literally a test. So if we have something like var a is 5 and var b is 6, and if we have var c is false, so if we write something like a is less than b and not false, and not c, and then actually I'll do it the other way. If not c, we do nothing, else we print something. We print no comparison, and here we will print console. CV actually is the short. We'll interpolate the string saying A, B, and then result and B, and then result will be A more than B. So the point is that instead of writing this, we can simply write this and switch the if statements. So this is what negative conditional is. You should avoid this. And of course, in C# we can simply write the Turner operation, where use the Turner operator, where we no longer need to write if-else and can simply determine which value we need based on the logical value. So don't use logical conditionals. Now back to slides. And what do we have? Two more points that I wanted to cover. So first, comments. Comment quickly becomes inaccuracy, a gossip, which in time transforms into a lie. So my point of view is comments are in most cases a bad thing and they should be annoyed. So why you do not need comments? Because code is expressive enough. You can write code which speaks for itself. And a good name is 1,000 times better than a good comment. Comment is noise. When you read a comment and you read a line of code which is for which you wrote a comment, you read 2 lines, so it disrupts readability. So the next time when you write a comment, you should feel a bit ashamed of yourself. You should feel defeated because as a programmer you were not able to express yourself good enough and your code was dirty, since you had to explain why or what you did it. So when do you need comments? For learning purposes, for consequences, and for clarifications. Those are the 3 points, and I will quickly run through each soon. The middle picture, the one on the bottom, when you delete a block of code that you thought was useless, this is the one of the best pictures illustrating why comments are so great in some cases. Sometimes it could be obvious, hey, this code is shit. It could be done much more simple. It could be done much better, easier. Why are there so many checks? Why does it use this structure? Why is it using a single thread and locking the UI? It should be a task, a sync, or something like that. But then you see a comment explaining all your questions, answering them. Imagine there was no comment and you deleted the code and did how you felt was right. So like in this picture, you would imagine you would cut a branch and the branch would fall, but instead you would cut the branch and the tree would fall on top of you. So you shouldn't leave places that you know are not obvious and you know you couldn't do better, that you know someone will try to do better, that you know someone will think like, what the fuck is this? Comment those places, always, unless you think of a better way of doing it, which would not need a comment in the first place, which would be obvious. Comment those. So for students, for anyone really who is working on a personal project and starting out with a technology, learning is a process and comments is a part of that process. Annotating your code, explaining what and why was written, what and why we wrote, really helps out in the process. Eventually, you should not use those comments, but in the learning process, they are really handy. It's funny how sometimes we wonder why it doesn't work, and then it suddenly works, but then we still wonder why. So imagine that your code was a mess, that it was not expressive. And then imagine yourself like that boy in the corner who comes after a year back to your project to which you gave no fucks, to which everything was named with vars and A's and B's and single letters, data as data, everything like that. And then you come to a project like that back and your boss tells you, we cannot send invoices correctly. There is some exception thrown. And you need to fix that. But everything is called data, everything is inlined, everything is a single name, single letter variable. So initially you estimate, it seems easy. 5 minutes, 1 hour. It will take 1 hour. But then you spend 2 weeks because everything was unclear and you had to refactor your code anyways. So this code written last month, I have no memory of this place. Exactly what happens when you write crappy code. So clarify if needed, but it's a lazy way of explaining what you should have expressed through code. So why don't you need comments? Code speaks for itself. A good name is better than a good comment. disrupts readability,